Okay, so in the previous section, the previous lesson, we found solutions to linear equations. So for example, if I look at this linear equation, x plus y equal 3, this equation, in the previous section, we saw that this ordered pair, 2, 1, is a solution to this equation. Now remember what we saw in the previous lesson. The reason we know that this is a solution to this equation is because when I substitute the value of x, which is 2, and the value of y, which is 1, into the equation, the left side will equal the right side. Now remember, this is called an ordered pair. Okay, so the values x, y, so this point is called an ordered pair. Okay, so if I, remember we're saying this is a solution. So if I substitute in place of x, if I substitute 2, in place of y, substitute 1, the left side has to equal the right side. So this equation will be a true statement. So remember what we did in the previous lesson. So we said if x is 2 and y is 1, 2 plus 1 is 3, and so that is a true statement. All right, so if I look at the point 0, 3, 0, 3 is also a solution to x plus y equal 3, because if I substitute the value of x, which is 1, the value of x, which is 0, and the value of y, which is 3, into the equation, I get 0 plus 3, and that is a true statement. So 0 plus 3 does equal 3. All right, but there are many more. In fact, there are an infinite number of solutions here. So for example, these points, these ordered pairs, are solutions to this equation. All right, so negative 1, 4, the ordered pair 3, 0, and the ordered pair 6, negative 3 are solutions to x plus y equal 3. And in fact, if you really look at this, you will see that there are many, many, many more solutions. You can come up with a lot more. So if we graph these ordered pairs, so in the previous lesson, we looked at graphing ordered pairs. So if I graph these ordered pairs, and so if I start with the ordered pair 2, 1, so 2, 1, so remember, to graph an ordered pair, you store the origin. Since the x value is positive 2, I'm going to go to the right 2 units. And since the y value is a positive 1, I'm going to go up 1 unit. So I go store the origin, remember, store the origin. And so I go from 2 to the right and then 1 up. So there's the point 2, 1. Now, in the problems, you will probably be asked to label. If it says label, that's what I mean by labeling. You're going to tell me what that point represents. So that point represents the coordinates 2, 1. It represents the ordered pair 2, 1. If I continue on and I plot the next point, 0, 3, so if I plot the point 0, 3, and I'm going to restore the origin. Since x is 0, I stay at the origin. I don't move left, right. Since y is positive 3, I'm going to go, and it's positive, I'm going to go up 3. So this is the point 0, 3. So that's the ordered pair 0, 3. And then if I plot these points, which we indicated were solutions to this equation, so for example, if x is 6 and y is negative 3, you can check to see that that is a true statement. 6 plus a negative 3 is 3, and that's what we wanted it to equal. So if I plot those points, negative 1, 4, 3, 0, 6, negative 3, that's what we get. So negative 1, remember x is negative 1, so you can go to the left this time, negative 1. You can go to the left 1 unit. Y is a positive 4, you're going to go up 4 units. 1, 2, 3, 4. So this is the point. If I label it, that's the point, negative 1, 4. 3, 0. So remember this time x is 3 and y is 0. I'm going to go to the right 3 units since x is positive, and then since y is 0, I'm going to stay there. So there's the point, 3, 0. And then 6, negative 3, if I plot that point, 6, negative 3, I'm going to go to the right 6 units, and then down 3 units since y is negative. And so there's the point 6, negative 3. Okay, now, you'll notice that if you look at this pattern, if you continued on, remember all we graphed here, all we plotted here was 1, 2, 3, 4, 5 ordered pairs. And remember, those ordered pairs are solutions to this equation, x plus y equal 3. So they're solutions to this equation, x plus y equal 3. If you look at the pattern, you should notice something about this pattern. All these points lie on a straight line. So all these points lie on a straight line. So if you connect those points, they would all be on a straight line. So if I take a ruler, a straight edge, and I plot and I draw a line to those points, we're going to see what's going to happen. So we're going to have a little discussion about this. Let me go ahead and get a ruler, and we're going to graph this. Okay, so if I look at if I graph this, and notice, see this how these points lie in a straight line? They're all collinear. I'm using the word collinear. Collinear meaning that these points lie on the same line, on this straight line. So if I connect them like this, and whenever you graph it, just make sure you go through the points and you draw arrows on both ends. Now I want you to make a note of this. So even though we plotted these points, 5 points, that doesn't mean that those are the only solutions. Those are not the only solutions. There are an infinite number of solutions. In fact, if I were to look at this point here, 8, negative 5, if I were to look at that point, and if I were to plug in, see right here, 8, negative 5, and if I were to substitute these values into this equation, x is 8, y is negative 5, I get 3. So that is also a solution. So the point that I'm trying to make is that any point on this line, this point, this ordered pair, and so on, is a solution to this equation. So a linear equation, this linear equation, has an infinite number of solutions. There's an infinite number of solutions. And so since we use the word infinite, there's no way you can list the solutions. There's not a finite number. There's an infinite number. So the way we do this is to graph the line. So when we graph a line, when we graph the linear equation, we are indicating the solutions. Okay, so every ordered pair on this line is a solution. Okay, so let's look at this. Let's look at this ordered pair right here. Let's say we want to look at the ordered pair 7, 6. So the question is this a solution? That's the idea. So is that a solution? Well, it doesn't lie here. It doesn't lie on this line, so it's not going to be a solution, but let's see why. So if I go back here, let me go ahead and do it here. And I substitute the point. Remember, this is the point 7, 6. And I substitute that point into this equation. The question is, remember, x is 7, y is 6. So is 7 plus 6 equal to 3? And the answer is no, because 7 plus 6 is 13. So that's why this is not a solution. So whenever you graph a linear equation, you're graphing the solutions. So if the ordered pair does not lie on the line, then it's not a solution. Okay, so that's the idea of graphing linear equations. You're graphing the solutions. Okay? All right, so now let's look at this. Okay, so we just said that x plus y equal 3 is a linear equation, And notice that there are two variables here. There's a variable x and the variable y. So this is called right here, we're going to say this is a linear equation, in two variables. A linear equation in two variables. So in your previous lessons, you dealt with linear equations in one variable and then linear inequalities in one variable. Now we're looking at a situation where we have linear equations in two variables. So a linear equation in two variables, the graph is going to be a line, and this line and the lines could fall down like this. It could rise up. It could be horizontal. It could be vertical. So we're going to have the discussion about all these types of lines that you can have. But let's talk more about what a linear equation in two variables are. All right, so linear equation in two variables. All right, so first of all, remember that a linear equation in two variables is a straight line. Okay, so a linear equation in two variables is a straight line. So when you graph these linear equations and you're dealing with two variables, the graph is going to be a straight line. The solutions of the linear equation will be every point on that line. So there's going to be an infinite number of solutions. So in terms of the definition, let's talk about what a linear equation in two variables looks like. All right, so linear equation in two variables. So here's the definition. So a linear equation in two variables is an equation that can be written in the form ax plus by equals c. So some number times x, remember that the number that you multiply the variable by is called the coefficient. So this coefficient times x plus this coefficient times y equal c, which we call a constant. All right, so x plus by equals c. And there's some other stipulations here, and that is where a, b, and c are real numbers. So a, b, and c are real numbers. And also a and b are not both 0. A and b are not both 0. Okay, so one of them, either A or B, one of those can be 0, and you're going to see this as we work through these lessons. But they both cannot be 0. Okay, and the reason is this. So let's understand why they both cannot be 0. So if this is 0, 0 times x is 0. And again, if b is 0, 0 times y is 0. So 0 plus 0 is 0. All right. So if they are, remember they can't, but if they are both 0, we have this. We have this side being 0, and the other side being some real number. Let's say 4. Well, notice that 0 cannot equal 4. That's not a true statement. Okay, so that's why they both cannot be 0. We cannot have a linear equation where both the coefficient of x and the coefficient of y are both zeros. Okay, so that's why we have that statement. All right, now whenever it's in this form right here, see how we have the variables on both on the left side and the constant on the right side? This is called standard form. Okay, this is called standard form. So that's standard form. All right, and then remember the graph of this is a straight line. Okay, all right, now here's some examples. These are examples of linear equations. So examples of linear equations. All right, examples of linear equations. So here's some examples of linear equations. X plus 3y equal 4. That's an example. Remember, ax plus by equals c, standard form. So in this case, if see how this looks exactly like this. So a is 1, b is 3, and c is 4. 2x minus 4y equal 6. That's another example. It looks exactly like this. A is x. Now remember, we talked about this in previous lessons. The coefficient of y is not 4. The coefficient of y is a negative 4, because remember, we can always rewrite subtraction as an addition problem. So you can rewrite this as 2x plus a negative 4y equals 6. So you notice that the coefficient of y, b, is negative 4. So a is 2, b is negative 4, and c is 6. Now, that's an easy kind. We also, if you look at this, we have y equal 3x plus 4. That is also a linear equation in two variables. Even though it's not in this, it's not written in standard form, we can rewrite this in that form. So remember, all you got to do is bring the variables to the left side and the constant on the other side. So bring the variables to one side, constants on the other. So if I bring the variables 3x over to the other side, I get negative 3x plus y equal 4. So a is negative 3, b is 1, and c is 4. Okay? In a little while, you're going to see these. Y equals 6, x equal negative 2, something like that. So notice that here this is still a linear equation, although you may say, well, there's no x. It doesn't look like this. Well, but remember, in our definition a while ago, we said this. We said a and b, one of these, can be 0, but not both. So if you look at this, b, the coefficient of y, b is 1, but you don't see the x term. So I want you to notice that you can rewrite this equation like this: 0x plus y equals 6. So do y'all agree that 0 times x is 0 and 0 plus y is y? So see, in this case, one of the coefficients is 0. So this right here, y equals 6, is a linear equation in two variables. Same thing here. The variable that's missing is y. Knowing that, and knowing that we can have either a or b being 0, I can rewrite this as x plus 0 times y equal negative 2, because 0 times y is 0 and 0 plus x is x. So a is 1, b is 0. All right, so that goes back to the fact that either a or b can be 0, but they cannot both be 0. And so that's where this comes in. All right, so these are easy to see that those are linear equations. And now you can see that if you are missing a variable, it's still a linear equation because you can rewrite it with a coefficient of 0. Now here are examples of equations that are not linear. Okay, examples of equations that are not linear. Okay, number 1, x squared plus y equals 6. That's not a linear equation. You're going to learn next semester that this equation is quadratic. This is a quadratic equation. That's a quadratic equation. All right, now remember, for us right now, just remember that in order for it to be linear, it's got to look like this. X to the first, a times x to the first, plus b times y to the first. So in other words, the exponents of the variables must be 1. So if you look at this, the exponent of y is 1, but the exponent of x is 2. So the fact that the exponent of x is not 1 makes it not linear. So if that was not a 2 here, if that was just x plus y equals 6, then it would be linear. But this is x squared plus y equals 6, so that's not linear. In fact, you're going to learn that that is going to be quadratic. That's a quadratic equation. The graph is not going to be a straight line. All right, number 2. Here's another example. Y plus 3 equals the square root of x. Y plus 3 equals the square root of x. So what makes it not linear, see, the y is fine, y to the first, but this, the square root of x, is not the same as x. Now, you're going to learn soon, you don't know why now, but you're going to learn soon that the square root of x is going to be x to the 1/2. So notice that it's the same as x to the 1/2. So notice that this exponent is not 1, but we're going to learn that in a future lesson. All right, so remember you got to have y to the first, x to the first, and the square root of x is not the same as x to the first. Square root of x is not the same as x. Okay, kind of makes sense, because if you have the square root of 4, is that the same as 4? And the answer is no. The square root of 4 is 2. Okay, square root of 4 is 2. Also, here's another example, and that, see, this part here is going to come into play in Math 99. This one here is going to come into play. Let's say we have 1 over y equals 6 in college algebra. So the reason why this is not linear, and so it's not because of the term 3x, because that's x to the first power, but it's because of this. Your variable, see how you may say, well, that's y to the first. Yeah, it is y to the first, but the variable cannot appear in the denominator. All right, so if you go back over here, this is ax divided by 1 plus by divided by 1. All right, so notice that the variable y is in the denominator. Okay? All right, so this, for right now, in this little part 1 right here, all I wanted to do was to understand what a linear equation is, and know the fact that when you graph a linear equation, you are graphing the solutions. And also know that when you graph a linear equation, there are an infinite number of solutions. Any point on this line is a solution. Any point not on that line is not a solution. Then I need for you to understand the definition of linear equations. The definition of a linear equation is an equation that will be written in the form ax plus by equals c. And if the variable's on the one side, the constant's on the other, then that's called standard form. We're going to use that word again in future lessons. And know that a and b cannot both be 0, but one of them can, and that helps us with understanding why these two equations right here are linear, even though there's only one variable that you see. Okay? And then notice, be able to determine if an equation is given, whether it's linear or not. All right, so that's going to be the end of part 1. In part 2, we're going to be given linear equations, and we're going to be graphing those. So that's going to be the idea in part 2.